So for the last few videos, we've seen examples where we take we have equations involving square roots. But what about situations where we have the root index greater than 2? So this is where we have the third root or fourth root or fifth root or just the nth root in general of a of a an expression or a number or whatever. We want to involve that in an equation. What do we do in those situations? Well, it's quite simple. This is true for all n. If we have a little rule here, if we have a equals b, then a to the n is equal to b to the n for any n. Okay, that's a good little rule to note here. Okay, and we're going to generalize our previous rule. Another rule. Okay, we said before that if we raise it, if we have to square both sides, we have to check our solution. Really, what we're going to say here is raising both sides of an equation to any even power means we're going to have to check our solution. Okay, so anytime we raise both sides of an equation to an even power, we must check our answer. Okay, this is really important because if you raise it to an even power, you may end up in a situation where you have no solution. And we'll see an example of that here in just a couple of minutes. So let's go ahead and look at a pretty simple one first, though. Okay, here we have the fourth root of x is equal to 3. All right, so to undo this, just like when we have the square root of something, we just square both sides. Here, if we have the fourth root of x is equal to 3, we're actually going to just raise both sides to the fourth power. Okay, so we have the fourth root of x raised to the fourth power. That'll just undo that. So we'll have x is equal to 3 to the fourth. Now, 3 to the fourth is equal to 3 times 3 times 3 times 3. Okay, and that's actually just going to be 81. Okay, but to check that, we just want to make sure that the fourth root of 81 is actually 3, which it is. So some of these are going to be pretty straightforward when we check our answer. Let's see. So we have the fourth root of 81. That is just 3, right? So that does check out, right? You can check that on a calculator if you want, or you can recognize that by realizing 3 times 3 times 3 times 3 is 81. Okay, pretty simple. How about this one? We have the fourth root of x is equal to negative 5. Okay, so let's go ahead and raise both sides to the fourth power here. So here we get x is equal to negative 5 times negative 5 times negative 5 times negative 5, right? Or negative. So here we have negative 5 times negative 5. That's positive 25 times negative 5 is negative 125. And then times negative 5 again, that'll give us a positive 625. All right? But if we have the fourth root of 625, okay, that's actually going to give us just a positive 5, which is not negative 5. So therefore, we have no solution. Okay? So again, this just shows anytime you raise something to an even power, you're going to have to check your answer. If you raise it to an odd power, you will not have to check your answer. Well, you should check your answer if you have time, especially if there's a lot of steps to it. These are pretty simple examples, but let's say you have something where you have an actual expression inside of your radical here. it would be wise to check your answer if you have time. But it's not an absolute necessity, because you're probably not going to end up with extraneous solutions if you have odd powers here. So this last one, we have the third root of w, or the cube root of w, is equal to 4. All right, so to fix this, we just raise both sides to the third power. Okay, and we'll end up with w is equal to 4 to the third, or you can think of this as 4 times 4 times 4. So, but we know that 4 to the third is 64. Right? So w should be equal to 64, and we know that the third root of 64 is just 4. So this checks out, and w equals 64 is our answer.